So here are the class notes on factorisation. So we've already seen how to multiply brackets out. So for example, if you see 3 and then brackets 2x plus 7, it means 3 times everything in the bracket. So I've kind of tried to colour code this. So orange here, 3 times 2x gives you 6x. And then in the green, 3 times 7 gives you 21. So 3 times brackets 2x plus 7 is the same as 6x plus 21. Now, that's multiplying brackets out. Factorisation is the reverse of that. So if you want to go from the 6x plus 21 and write it as something times a bracket, it's that process. So factorisation is going from 6x plus 21 back to 3 times 2x plus 7. And well, there are reasons that you might want to do that you'll see later on in maths. It does help make some things easier to solve if you've got them factorised. So for example, factorise 8x plus 32. So I'm asking myself, what is the biggest thing that I can divide both 8x and also 32 by? So the biggest thing that you can divide both of those by is 8. You can divide 8x by 8, and then you can divide 32 by 8. So I'm going to take 8 outside of the brackets. So 8 is my number that goes outside the brackets. And then I'm asking myself the question, what have I got to have inside the brackets to get the thing I started with? So if I've got 8 outside the brackets, what do I need to multiply that by in order to get 8x? And the answer is an x, so I need an x inside the brackets because 8 times x gives me 8x. And then I'm asking myself the question, what do I need to multiply the 8 by in order to get a 32? So the answer to that is that I need a 4 inside the brackets because 8 times 4 will give me the 32 that I started with. So 8x plus 32 is equivalent to 8 brackets x plus 4 close brackets. So here's some examples from the book. 8d plus 40 factorised. So the biggest thing that 8d and 40 can both be divided by is 8. Now in order to get the 8d, I need to multiply the 8 that's outside the brackets by d, so I have a d inside the brackets. And then in order to get the 40, I need to multiply the 8 that's outside the brackets by a 5, so I have a 5 inside the brackets, and 8d plus 40 is equivalent to 8 brackets d plus 5. Another one from the book, 5x minus 25x squared. So 5 and 25 can both be divided by 5, but also both of these have got some x in them. So in fact I can divide both of these terms by 5x, and then I ask myself the question, what have I got to multiply 5x by inside the brackets in order to get the thing that I started with? So 5x, I just need to multiply by 1 in order to get a 5x, but then I'm asking myself the question, 5x times what will give me minus 25x squared? Well, I'll need a minus there to get the minus. I'll need to multiply the 5 by 5 to get the 25, and I'll need to multiply the x by another x to get the x squared. So I need minus 5x inside the brackets, so that 5x times minus 5x gives me minus 25x. Okay, the next one, 9x squared minus 45x minus 27x squared. So I've got a mixture of x's and numbers there. 9 and 45 and 27 can all be divided by 9, so I can take a 9 outside the brackets. And then x squared, x and x cubed, they can all be divided by x, so I can have an x outside the brackets. So all of these terms can be divided by 9x. Then I'm asking myself the question, what do I need inside the bracket when so that when I multiply it by the 9x, I get the thing I started with. So 9x outside the brackets, I need to multiply it by an x in order to get 9x squared. 9x outside the brackets, I need to multiply it by minus 5 in order to get minus 45x. And then 9x outside the brackets, what do I need to multiply that by in order to get the minus 27x cubed? Well, the 9 needs to be multiplied by a 3 to get 27, or in fact a minus 3 to get minus 27. So I've got a minus 3 there. But then also the x needs to be multiplied by x squared in order to get the x cubed. So 9x squared minus 45x minus 27x cubed is equal to 9x brackets x minus 5 minus 3x squared, close brackets.